Okay, to this far, we've understood the concept of an array. We've seen how we can declare arrays in Fortran, how we can initialize values, different methods of initializing values. We saw that you could do so by initializing during declaration or after declaration in the assignment statements, or maybe even using the read statement to initialize your array values. We also saw the concept of array constants or constant of arrays, where you would use the array constructor to initialize values to our arrays. In this video, probably our last video, we are going to look at whole arrays operations. So we would want to see between the whole array and things that we can do with the whole array, and probably the subsets of arrays and things that we'll be able to do with the subsets of arrays. So we are saying under certain circumstances, whole arrays may be used in arithmetic calculations as though they were just as ordinary variables. So we should remember that an array is not just an ordinary variable. An array is a special variable because it has got many values which are known by a single name. So, but we may want to use arrays sometimes as if they were ordinary variables in our maybe arithmetic calculations. So here we are showing you such an example. Of course, we've had similar thing before, but only that we did not introduce you as a whole array operations or as a name here is implying. But let's see here. If we have an array of 4 elements, and we call this array A, and another array of 4 elements, we call this array B, we can add these two arrays together, we can multiply them, we can do whatever, we can apply arithmetic operations on the elements. So if we add them together, then what it means is the first element will be added to the first element of the second one to give us the first element of the container or array that we are using to keep the result. So this plus this will give us this. So it's the element by element addition. That's what you can do with whole array operations. The moment you add array name with another array name, then their elements, corresponding elements will be added. Or if you have an array and you multiply it with something, then each and every element will be multiplied by that value. Here we are demonstrating something small. We've declared an array A and array B of size 4 with the initial values given. These are real values. And we have array C and D which have not been initialized but of the same dimension, 4 as a size. Okay, so here we are adding using a loop. We are adding A plus B element by element ourselves. Naturally, how things are supposed to be added in arrays. So we are taking element on index 1, adding it with element on index 1 on the in the other array, and assign that value to index 1 for the result array. So this will continue up to 4. Then all elements will be added up. But we are saying instead of element by element addition, you can use a whole sum array addition. You can add them together by just writing something like A plus B, then that will be assigned to a container that you want to keep it with. So maybe D. If you are to display the elements of C and elements of D, probably you are going to find them the same. So this operation and this operation is achieving exactly the same thing, adding corresponding values element by element, only that this one is a much shorter than using this. This is verbose. So in Fortran, you can use whole array arithmetic to handle arrays as if they were ordinary values. Okay, and we have sometimes also we may be interested in sometimes just to deal with a section of an array. Instead of working with the whole array, we can just be interested in maybe a certain section of an array, which we call a subset. So a subset is an array of an array is a section. So for us to come up with a section of an array, we have to specify what we call a subscript triplet, or we can specify vector subscript. We're going to see vector subscript later, but here let's start with a subscript triplet. So the general format is you have your subscript 1, then subscript 2, then the last one you specify the stride, the criteria, how many maybe elements should be jumped in between. Should it be from element 1 to element 2? Probably you can put 1 as a stride. If you put 2, it means it will be jumping 1 element. So any or all of the components of this can be specified or can be defaulted. So you can specify just maybe the last subscript and the slide, or maybe you can have first and second without having the stride, and it will be using the default ones. For example, here we have an array which has got 10 elements, and we can have a subscript 1 to 10, 2. So we want to start from 1 up to index 10, but we'll be jumping 1 index in between because we are using a subscript of 2. So this is as good as having element number 1, then element number 3. So it will pick 1, then 3, then 5, then 7, then 9, because we are jumping. If we had 1 here, then it means we are not even getting a subsection, because that one would give us everything in that array. Okay. So you can try to work on this one and try to maybe use some default values or skip some values. For example, instead of 1, you would just have colon as your starting statement inside here. Colon maybe 10, then colon you specify the stride. Or you would start with 1, then colon dash, then colon stride, something like that. So you can try whatever you want. Try to work around the subset of arrays. Subscripts, triplets that we have had, select ordered subsets of an array for use in calculations. But vector subscripts allow arbitrary combination of an element to be selected for use in an application. So there's a little bit of a difference between the two. So the subscript, we need to have ordered subsets of an array elements for use in calculations. As we saw here, you specify the starting element and the last element, and you specify the stride. So it will be moving from that going towards the end. While with vectors, you don't have any order. You can just specify the indices for the arrays that you are interested in. So a vector subscript is a one-dimensional integer array specifying the array elements to be used in a calculation. It can be specified in any order. This is very important. In any order, unlike using subscript triplets where you have the starting and the ending. This one is in any order. You can specify maybe element number 5, then 1, then 7. So you are just interested in these 3. Here we are showing a vector subscript, where we are having a vector array of 1, 6, 4, 1, 9. And we have our array of 10 numbers here, 1, -2, all the way up to 10, which is a real array. And we want to get just a subsection of this. And a subsection we can get by specifying the name of the array and the name of the one-dimensional array, or the array that is used as a vector. So here it means we are looking at only elements that are available, or that should be available on the index 1, which will be 1 point, and on index 6, 1, 2, 3, 4, 5, which will be -6, and on index 4, which will be -4, then on index 1 again, which will be 1, then the last one on index 9, which will be 9. So this is how you can specify the elements that you want to use in your calculations using a vector subscripts. Lastly, we would like to look at a concept of allocatable arrays. In the old days, the maximum size arrays had to be declared when the code was written. So the examples that I've shown you, we've always been specifying the maximum number of elements that can be used or stored in that array. So this has been the order in the past, but now we are saying this, of course, it has got its advantages, but people to have maybe very big, or if they are not very sure of how many elements they will have during the time of coding the program, they will end up just giving a very big size, maybe allocating 1000 as the maximum number of elements that can be used, because they are not sure, but maybe not all of them will be used. So there's a solution. A solution is to use a dynamic memory allocation. So you allocate your arrays dynamically during the runtime, not during the compilation time. So with that, for us to come up with an array that does not know how many elements it is going to have during the declaration, but when we are running our program, we can specify the size of array that we want. Then we have to use the following. When you are declaring your array before the dimension, you have to actually specify the attribute allocatable. So we have just added this allocatable, and we can see that for one-dimensional array, our dimension is just colon, which is just like a placeholder. We don't have anything. We don't know how many elements this array will need, so we have just put a placeholder, but this is an array. So okay, all these are just some of the important things that may need to be there, but I want to show you here. Here we are now asking a user to enter how many elements he wants. So with this one, somebody may say 10. If he enters 10, then the program is going to allocate a space for 10 elements. If somebody enters 4, it's going to allocate spaces for 4 elements, etc. So we have 10, for example. Then if our n is 10, then this is going to allocate an array of 10 elements. And of course, you can specify this if you want to get a message when something is successful. It gives you a message which you receive using a status variable declared here, or you can have an error message which is specified, or you receive it using this. Of course, the error message is not supposed to have the underscore here, just supposed to have it as one word, ERRMSG. Okay, so this is how you do. Of course, when you have used your array which you dynamically allocated, you must deallocate it by using deallocate. So here we have allocate. Now we can use deallocate to remove the memory that you dynamically allocated. So that should mark the end of our chapter on the arrays. And for further reading or understanding of arrays, you are encouraged to go through chapter 7 in our main reference book, as well as chapter 6 of this another reference book, which is Fortran for Scientists and Engineers. Thank you.